2019 intake, and we are from group C3.
And today we will do experiment 8 thermal conductivity of liquid and gases. Okay, let us introduce ourselves. So my name is Nasrina, and my name is Siti.
My name is Jennet Lay Sei Yee, and my name is Yap.
Objectives. For experiment A, to calibrate the unit by establishing the incidental heat transfer. For experiment B, to determine the thermal conductivity of liquids and gases.
Now we will see about the apparatus of the experiment. Let's go.
Power indicator, temperature controller, temperature indicator, temperature selector, heater switch, power regulator, main switch, thermocouple, top sample port, jug cylinder, bottom sample port, the cold and hot water inlet and outlet. Methodology. General startup. The electrical supply is turned on. The power regulator is turned to fully anti-clockwise. Make sure the cold water supply is connected. The main switch is turned on and the unit is ready to be used.
Procedure experiment part A. Air is used as the sample for the calibration. Make sure the temperature controller is set to 65 degrees Celsius. The heater switch is turned on. The power regulator is adjusted to ±7 watt. Ensure steady state condition is achieved before the readings are increased and regulated with other values. The temperature data is observed and recorded. Step 1 until 6 is repeated 4 times with constant increment of ±7 watt. Procedure experiment part B. For gas sample, the power regulator is adjusted to 25 volt. The step is followed as in experiment part A. For experiment with acetone sample, acetone is injected into the sample port from bottom by using a string. Ensure no air is trapped inside the sample pot. The power regulator is set to 100 volts. Step 5 to 6 in experiment part A is repeated for acetone sample. For both experiment part A and B, thermal conductivity for fluid is determined and recorded. The result obtained is compared.
General shutdown. The power regulator is turned fully anti-clockwise and the heater switch is switched off. The main switch is switched off. The electrical supply is switched off and the cable is unplugged. The water supply is closed.
Results and discussion. Table 1 display result obtained for experiment part A. From table 1, T1 is temperature at inner cylinder. T2 is temperature at outer cylinder. Temperature difference is calculated by using T1 minus T2. Electrical heat input Q generation is equals to power supply to heater. Heat conducted through a QC is calculated using Fourier's law. Incidential heat loss Q loss is calculated by using Q generation minus QC. Figure 2 displays the graph of incidential heat loss versus temperature difference. From the graph obtained, we observe that the higher the temperature difference, the higher the incidential heat loss.
The discussion for experiment part A. The higher the power supply to the heater, the higher the temperature increase, the higher the thermal conductivity that we can obtain. Fourier's law is the basic of conduction heat transfer and used to calculate the rate of heat conducted through air.
Table 3 displays result obtained for experiment part B. From Table 3, T1 is temperature at inner cylinder, T2 is temperature at outer cylinder. Temperature difference is calculated by using T1 minus T2. Electrical heat input Q generation is equals to power supply to heater. Heat conducted through air QC is calculated by using Fourier's law. Incidential heat loss is calculated by using Q generation minus QC. Theoretical thermal conductivity K value of fluid is obtained from the property table. Experimental thermal conductivity K value of fluid is calculated, and percentage area is calculated by using the theoretical thermal conductivity and experimental thermal conductivity value.
The discussion for part B. The calculated value for air and acetone of thermal conductivity is not equal with the tabulated value. There is percentage error between the theoretical thermal conductivity and experimental conductivity value. The percentage error for thermal conductivity of air is 3.85%, while for acetone is 6.25%. However, the error is less than 10%, so the result of experiment is accepted. For gases that the thermal conductivity has a low value, while the thermal conductivity for liquid is between solid and gases.
Overall, the experiment succeeded in showing the main findings for the two parts of the experiment, which is to observe the thermal conductivity of gas by establishing the incidential heat loss and the thermal conductivity of liquid and gas samples. In the first part, after calibrating the different reading of power, which is 6.3 watt, 13.3 watt, 21 watt, 27.9 watt, and 34.7 watt, the result we obtained is near to the Fourier's law theory, as the initial heat loss is proportional to the conductivity of the gas and the temperature. As the power supply increases, the temperature of the apparatus increases and leads to the increase of thermal conductivity of the gas. The calculated percentage error is less than 10%, hence the result of part A accepted. In part B, we determine the thermal conductivity of liquid and gas samples using Fourier law. The fluids that we use are acetone and air. The result we obtain is not equal with the theoretical value because the system did not reach total steady state. However, the result has still complied to the Fourier's law as the acetone has a high thermal conductivity of liquid, which is 0.15, and air is 0.027 because it has a lower thermal conductivity in the state of gas. Meanwhile, the calculated percentage error is small and less than 10%, therefore the result of part B accepted.